Okay, class, we're about to start section 4.1, Introduction to Fractions and Mixed Numbers. Section A, identifying numerators and denominators and reviewing division properties for 0 and 1. In a fraction, the top number is called the numerator and the bottom number is called the denominator. The bar between is called the fraction bar, which is illustrated here. We have the numerator, denominator, and this is the fraction bar. Now this is what these mean. The numerator means the number of parts being considered, and 6 is the number of equal parts in the whole. Now this will become very important later. Okay, here, identify the numerator and denominator for each fraction. Remember, the numerator is at the top, so it's numerator. Denominator is at the bottom, denominator. 10 is the numerator. 17 is the denominator. Now it says, before we continue, we must remember that fractions are just a form of division, which we covered back in section 1.7. So let's review two division properties for 1 and 0. We know any number except 0 divided by itself is 1. It says let n be any whole number except 0. So any number divided by itself is 1. Any number divided by 1 is the number itself. 0 divided by any number but 0 is 0. And n divided by any number except 0 is undefined. Now, examples. We have write three fractions that are equal to 1. So we have 5 over 5. We have negative 3 over negative 3. And we also have 10 over 10. I'm going to throw in the extra one. We could have x over x with x not equaling to 0. And that equals 1. Now number 2, it says write three fractions that are equal to 0. So we can have 0 over x, where x does not equal 0. We can have 0 over 7, 0 over negative 12, and we can have 0 over 1. It says write three fractions whose value is undefined. We can just flip these over: 7 over 0, negative 12 over 0, and 1 over 0, and also just add in a fourth one, x over 0, when x is not equal to 0. All of those are undefined. It says write three fractions that are equal to integers. Now integers are positive or negative numbers that do not have a decimal or fraction with them. So they said three fractions that are equal to integers. So we could have 5 over 1. We could have negative 10 over 2. And we could have, let's see, so we could have 14 over 7. It says write what fraction of the letter of the alphabet are vowels. Don't include Y. So first we must write out our vowels. It's A, E, I, O, U. Now some people say and sometimes Y, but it says don't include Y. So what we have here is the part we're going to consider, which is the vowels. So that's 5. And then we would divide it over the parts of the whole. How many letters are in the alphabet? 26. So it's 5 over 26. What fraction of the months of the year have more than 29 days? Now we know there's only one month out the year that has 29 days or less. And we know that month is February. So the whole part is 12. And the other month we're considering is 11. So our final answer here would be 11 over 12. Now we come to number 7. A box contains 6 blue marbles, 4 red marbles, and 3 white marbles. What fraction of the marbles are red? First of all, we know we have 4 red marbles. So this is the part that's being considered. But it must be divided by the whole. So 6 and 4 is 10 plus 3 is 13. So it'll be 4 over 13. Now B, what fraction of the marbles are not white? So what we would have to do is this here. Your denominator would still be 13, and we would add up the marbles that are not white, which is 10. Now we move on to the examples. We want to simplify. Number 1, we have 8 divided by 8, which we know is 1. Number 2, 10 divided by 1, which is 10. Number 3, 16 divided by 0. We know any number divided by 0 except 0 is undefined. And now 0 divided by 17, 0 divided by any number is just except 0 is 0. Now, writing fractions to represent parts of figures or real-life data. One way to become familiar with fractions is to visualize fractions with shaded figures. We then write a fraction to represent the shaded area of the figure. In figure 2, in this figure, 2 of the 5 equal parts are shaded. Thus, the fraction is 2/5. So we have 2, which is being considered of the whole number of equal parts, which is 5. So it'll be 2/5. Now in this figure, 3 of the 10 rectangles are shaded. Thus the fraction is 3/10. So 3 of the 10 figures are shaded. So this is the number of parts shaded, or the number to be considered, divided by the number of equal parts of the whole. Now it says write a fraction to represent the shaded part of the figure. So first of all, let's do this. The numerator will be the shaded parts, which is 3. The denominator will be all of these added together. So that'll be 8. So your answer here would be 3/8. Now number 2. Again, your numerator would be 1. Your denominator would be all of these together, which is 6. So it'll be 1/6. Now it says draw and shade a part of a figure to represent each fraction. So 2/3 of a figure. So what we could do is we could draw a figure, break it into 3 parts. I know this isn't the best, but it'll work. And 2/3 of it is shaded. We'll shade this part, this part here. Now, of course, you can shade it all the way through. So this would be 2/3 of the figure that's shaded. Okay, 7/11 of a figure. Now, what I would do is I would do these circles. And then just shade in 7 of them. That'll be 7/11. Now we scroll down here to section C, identifying proper fractions, improper fractions, and mixed numbers. A proper fraction is a fraction whose numerator is less than its denominator. Proper fractions are less than 1. An improper fraction is a fraction whose numerator is greater than or equal to its denominator. Improper fractions are greater than or equal to 1. A mixed number contains a whole number and a fraction. Mixed numbers are greater than 1. In the previous examples, we used shapes and figures to represent proper fractions. So below we have visual representations of improper fractions and mixed numbers. Now we have this example here. The examples below represent the shaded part of each figure group's area as both an improper and a mixed number. Now if you notice here, these are 2 separate figures here. So if you look here, if we just did the shaded part would be 4. And what we would do is both of these are broken up into 3, so it'd be 4/3. Now, the mixed number, we have one whole figure shaded. That's where we get this 1 from. and 1/3 of another figure that's shaded. So this is 1 1/3. Now we come here. This is broken up. All of these figures are in 2s, and there are 3 separate figures. So what will end up happening, we will count the shaded parts, which is 5. And then our denominator would be 2. Now the mixed number, we have 2 whole figures shaded and a half of one. So that's how we get 2 1/2. Now note, in problem 1, the mixed number 1 1/3 represents 1 plus 1/3. So what do you think the mixed number in problem 2 represents? You got it. It'll be 2 plus 1/2, which is 2 1/2. Now section C, it says identify each number as proper fraction, improper fraction, or mixed number. You could write just proper, improper, or mixed. We know this is mixed. This is improper, because the number on top is larger than the number on the bottom, or the numerator is larger than the denominator. We have 8/9. The numerator is less than the denominator, so this is a proper fraction. 2 1/5 we know is a mixed number. 5/5, we know that this is also considered to be an improper fraction, because remember, improper fractions, the numerator and denominator are either equal or the numerator is larger. 0 divided by 4, we know that this is a proper fraction. Now remember, you can write the word fraction or mixed number here. Well, let me write that in. Mixed number, improper fraction, mixed number, proper fraction, improper fraction. And here we know this is improper fraction. And finally, we know that this is a proper fraction. Now we scroll down here. It says represent the shaded part of each figure group's area as both an improper and a mixed number. So we look here, we had 2 separate figures. They're cut up in fourths. So we know our denominator would be 4. We count the shaded amount. We have 4, 5 here. So it's 5/4. Now to get the mixed number, we have 1 whole figure that's shaded and 1/4 of another figure that's shaded. Now we come to number 2. Same thing, our denominator here would be 3. Our numerator would be 8. So that's 8/3. So now we will write this as a mixed number. We have 2 holes that's shaded, and then we're left with 2/3. So it's 2 2/3. Now it says the following steps may be used to write a mixed number as an improper fraction. Now, what happens here is this here. When you take a mixed number, you take the whole number times the denominator and add the numerator. This denominator stays the same. So 3 carries over all the way through. But we have 1 times 3, or 3 times 1 plus 2. And that would give us 5. So that would be 5/3. Now it says write each as an improper fraction. So 2 5/7. Our denominator stays 7. Now let's do the numerator here. We will have 2 times 7 plus 5. 2 times 7 is 14 plus 5/7. 14 plus 5 is 19/7. Now we have number 2. Our denominator stays 3. Our numerator is 5 times 3 plus 1. So that would be 15 plus 1 all over 3. So it would be 16/3. Now we had 9 3/10. 10 carries over. We had 9 times 10 plus 3. So it would be 90 plus 3 over 10. which is 93 over 10. And that's it for that problem.